Okay, this is component 3, mock 2, question 3. And it's got a picture of a rabbit, I can see that, and some lovely feces over here. Just what you want to see on your exam paper. So, the diagram shows the digestive system of a rabbit adapted to its high cellulose diet. It's a non-ruminant herbivore, so we're not going to be talking about rumens and chewing the cud. So what can we see? We've got the stomach first, liver as usual, so this looks pretty like ours. Going down to the small intestine with the pancreas, so that's the duodenum, small intestine, it tells us that's the site of absorption. It's got the functional cecum where the cellulose is digested, bizarrely a bit after the absorption stage, and then we've got the colon and rectum containing the fecal pellets, and the handy label to the anus. So, rabbits can produce alpha amylase to digest starch, but can't produce an enzyme to digest cellulose. With reference to the structure of starch and cellulose molecules, so this is all the way back, this is synoptic, back to the core. Explain why alpha amylase can't digest cellulose, even though they're both polymers of glucose. So, we're going to need to say something about the structure of starch and cellulose, and then something about enzymes. So, starch is made of alpha glucose, and cellulose of beta. I'm going to add the glucose in for the sake of it. Starch is therefore coiled and cellulose has straight chains. Now this should lead you really, if you know your structures, then that should lead you directly into, oh whoa, they're different shapes. So remember, link back to the question, why alpha amylase is unable to digest cellulose. So the two molecules are different shapes. Now I'm going to refer back to the question. Alpha amylase has an active site. Another bit of core there. That is complementary to starch. Or of course you could put that the cellulose won't fit into the active site because it's the wrong shape. Okay. Explain how rabbits are able to digest cellulose without being able to produce the necessary enzyme. So again, you know from doing herbivore digestion and ruminant digestion that the cellulase is produced by bacteria. That's the whole point of the rumen, isn't it? In the ruminant, it's you just chock-a-block with these mutualistic bacteria. So, here we go, coprophagy. That's a great thing to be looking at in an exam, isn't it? It's applied to the practice of eating feces. Do not do this at home. Not good for you. In rabbits, this is a natural part of digesting their high cellulose diet. It's noticeable that rabbits produce two distinct types of feces, soft and hard. Got to be honest, never looked. But they're the ones that they kind of leave around on the ground. They're done with those. So, furthermore, they are frequently seen eating the soft feces and the hard feces. Okay, for this reason, it has been suggested that the soft feces may be more nutritious. Again, what can I tell you? Don't be trying this at home. Some students decided to test this hypothesis by analysing samples for the presence of the main food substances, so starch and reducing sugar. So what reagent to use for starch? Again, this is synoptic, it's straight out of your practical book. You use iodine. And for reducing sugar, Benedict's. Now, if you have any sense whatsoever, you will have made yourself a little set of sort of cards or post-its or something with these tests and how you do them and what the results, positive and negative, are, because it's absolutely fundamental synoptic knowledge. So, the types of results they got for reducing sugars, the soft ones were orange and the hard ones are green. What does that mean? That means high sugar, yeah, lots of it, and that means low sugar. What conclusion could the students have drawn? So, which one is it? Soft. And of course you can do this either way round. So soft feces contain more reducing sugar than hard feces. This is a great question. Anyway, there we go. So, explain how rabbits would be able to detect this nutritional difference between the types of feces. Presumably this is leading into why they eat the soft ones and why they leave the hard ones alone. Well, if it's got more sugar in it, obviously they're going to taste sweeter. They might be able to smell the sugar in them. So, soft feces. And you can have the reverses, obviously. In this one you could have said, hard feces have less. So soft feces would taste or smell sweeter. And I'm making it all sound very appealing. You're going to say, don't try this at home. We're not reaching the end of the question yet, so over the page. With reference to the relative positions of the main organs of the digestive system shown on the diagram on page 8, and using all the information then given on page 9, oh good lord, explain the reason that they've got a nutritional difference. So I'm just going to remind myself that the soft ones, soft to sugary, so they've got more nutrients, and I'm just going to flip, you need to flip backwards and forwards. And here we've got absorption followed by cellulose digestion. So we've got absorption, then digestion, and then digestion. So really the whole point here, I think, is that they re-ingest their feces so that it can shove it through the absorption phase again. Rabbits really do this. Don't keep pet rabbits, disgusting. So, we need to put this into words. So, I'm going to start with the main organs of the digestive system because the question has, and then do the this bit. Okay. So, where to start? In the digestive system of the rabbit. The rabbit, the cecum containing cellulose digesting bacteria, after the small intestine which absorbs the product of digestion. So, this means the sugar from cellulose digestion is not absorbed and is digested. Presumably only in the soft feces. Presumably the hard feces have gone through twice. So by ingesting soft feces the food, don't really like to think of feces as food, passes through the gut twice, and the sugars can be absorbed I think that's probably enough. And you could probably go on and say, you know, the hard feces have been through twice and had their sugars absorbed. I think it's all covered in that.